Hello. In our next lecture, we're going to be talking about the second part of chapter 1, where we talk about measurements, significant figures, and unit conversions. So I'm just going to very briefly go over what each of these things are, so you'll be ready for class. So measurements are things that are taken a lot within chemistry. These are going to be a recorded value with both a value, numerical, and unit, which gives us information about the magnitude of the numerical value itself. So you want two things. You want a number and a unit that describes that number. So it defines a quantity, gives a quantity of a thing. Of a physical property. Right. So we will always have units here. We will always have a value here. And when we take a measurement, the numbers we put on there give us information about it. So the number with the amount of digits gives the precision of the instrument used to obtain the value. So we'll talk a little bit more about that when we talk about significant figures. And all of this we're going to talk about more in detail in class or in a further video lecture. But the number itself is important. And the unit itself is important. And we're going to look at units first. Our unit tells us, again, what our magnitude is. A lot of times we'll look at what's called SI units. And these are a decided upon system or set of units within the metric system. And these are used to basically give information about kind of the macroscopic world. So it's used to define measurements of the macroscopic variety. And we'll go over the specific SI units we'll be looking at in class. But let's look a little bit more at our metric system, which I spelled incorrectly here. Let me try that again. Our metric system is the unit system used in sciences. And by most of the world. So this includes things such as meters and grams, seconds, moles. All of these are considered metric units. And this is used for length, this is used for mass, this is used for time, This is used for amount of substance, like an actual value of substance, not necessarily a mass of a substance. So we could say we have this many of this substance. And we can use a prefix in order to show a base unit. So these are our base units in the metric system. And then we use a prefix again to indicate a magnitude. So they're used preceding a base unit in order to indicate a multiple or fraction of that base unit. Okay, and I'm going to give you guys a whole list of prefixes, but to kind of give you an example, some prefix examples includes kilo, lowercase k, centi, lowercase c, milli, lowercase m. So we've got lots of prefixes. And then when you attach them to a base unit, such as kg, that stands for kilogram. And that means we have 1,000 grams. So the multiple would be 1,000 there. All right, so for every 1 kilogram, we have 1,000 grams. And we'll go more over that and how to use the system. And within our SI units, I'll also give you which SI unit, so which of these metric prefix plus base unit you need to memorize as far as what's included in that SI system. So using these units, and we almost always use the metric units with their prefixes, but another system we look at is the English system, and that's probably what you're most familiar with. This includes stuff like pounds as a mass, inches for length, and so on and so forth. We can use volume, ounces. So lots of things we can use within the English system that are going to be different. And one of the things we're going to be doing in this particular lecture is we're going to be converting between English system and metric system. So if we say something like, I have 1 pound of iron, we want to know how many grams is that. In order to go from a pound of iron to grams of iron, we need to do a unit conversion. So we'll have the same amount, just different units will be preceding that. So unit conversions, we go from one unit to another. So if we have going from pound to grams, we would just look in a unit conversion table or a metric to English conversion, and we would see things like 1 kilogram is equal to 2.2 pounds. So this allows us to go from our English system to our metric system. And when you're trying to do conversions between English and metric, you have to find that one that goes between them and then move through. So that 1 pound of iron, you would use a unit conversion where, because 1 kilogram is equal to 1 pound, if we divide them by each other, that will equal 1. So we can multiply anything by 1. So using unit conversion is just like multiplying by 1. And that's also equal to 2.2 pounds over 1 kilogram. Here we have pounds on the bottom, or pounds on the top, so you need pounds on the bottom. So we would use this unit conversion. And the 1 kilogram would be on the top, 2.2 pounds, divided out. Giving us 0.45 kilograms. And then going from our kilograms to our grams, we already made this unit conversion where 1 kilogram is equal to 1,000 grams. So 1 kilogram over 1,000 grams is equal to 1. And then the opposite, or the reciprocal of that, would be the same. Here we have kilograms on top. That's our given unit. We want to convert into grams, so we want kilograms on bottom, grams on top. So 1,000 grams per 1 kilogram, giving us 450 grams. Now, you might ask yourself, how many decimal places? Like, I did 2 decimal places there when I divided it out. But when you actually do that math, you get 0.4545454545 repeating. And you might wonder, how can I tell how many decimal places to use? And this brings us into significant figures. So our significant figures tells us, 1, how precise the measurement is. So whenever we have a value, we can say how many significant figures that value has. And then, once we know how many significant figures a value has, we can determine, if we do some sort of calculation with that value, how many significant figures should our n value have. So with significant figures, we're going to look at rules for determining number of sig figs. And there's quite a lot, so I'm not going to go over them right now. But you're basically determining, is a 0 in the value significant or not? Because all non-zero values are significant, but only some of the zeros are. So our significant zeros are going to be those that are captive zeros, and then trailing zeros when the number includes a decimal place or a decimal. Insignificant zeros are going to be trailing zeros when no decimal is present. And then our other type of 0 is going to be the zeros that are at the beginning of a number. And we call these leading zeros. So leading zeros are always insignificant. Okay, like I said, we'll go more in detail about those, but all non-zero digits are significant, while zeros are significant if they're captive or trailing when we have a decimal, insignificant if they're trailing with no decimal or they're leading zeros. And then there are rules to determine number of sig figs or significant figures in a calculated So these are sig figs for measured values. And then if we have a calculated value, we have addition subtraction rules. And we have multiplication division rules. Okay. So when we are taking two values or multiple values and we're doing some sort of calculation with those values, we use two different sets of rules to determine if we have or what our end value significant figures will be. So if we have a addition subtraction, it's going to have, so the calculated value will have the same number of decimal places as the least precise value. If we have multiplication and division, the calculated value will have the same number of significant figures as the least precise value. So what you're starting out with. As I said, we'll go much more in detail about all of these things, but that's kind of an overview of everything we'll be going over in our next lecture. I will see you guys very soon. Have a good day.